Good afternoon, Math 105. Sorry, our stream is starting a little bit later today than I'm used to, so my apologies for that. Things have gotten kind of busy around the math department today. So we've got about 45 minutes or so together to push the ball forward a little bit more on the topic that we started talking about last week, which is how do we use linear equations? So an equation that describes a relationship between two measured quantities whose graph looks like a straight line. How can we use that strategy that we outlined last week in how we discover equations for and then discuss using various forms of communication that include verbal, written paragraphs, that include actual graphical representations, tables of data. How do we do all of that stuff with data that comes to us from the real world that might not be picture perfectly linear? After all, anytime we have to measure quantities out from the world around us, it's very rare, in fact, it almost never happens, that the data that we get back is going to precisely follow an algebraic model that we might specify for it. Almost always, measurement involves uncertainty. Even if there's an actual linear relationship out there in the world, if by the time we go to actually measure it, just the act of measurement is going to introduce a little bit of measurement uncertainty. And so there can be noise. Every data stream we think of as including a signal that's telling us something, but also some noise that can kind of obscure our understanding of the relationship that's actually there. So how do we see through that noise and talk about a linear relationship that might not be picture perfect on the nose? So what we're going to talk about this week is if I have a set of data points that suggest a linear relationship. First of all, how do we know that they're suggesting a linear relationship, even if it's not exactly spot on? And then, how do we choose and use some appropriate technological tools to discover not just a linear model that models our data, but hopefully the best possible linear model to model a given set of data? So those are the kinds of questions that we're going to be consumed with this week. Let's take a quick look at a starting point here. So the order of the day is going to be a technique that we call linear regression. And regression is just a fancy word taken from statistics to really just mean a process of fitting. And fitting is a loaded word here, so I want to talk a little bit more about what that means. But the process of fitting a model equation to a probably very large set of data points. So we get some data points from measurements probably taken from the real world. And then I want to use some tools to figure out how to put an equation on top of that data to model the behavior in that data as best as any equation of its type can do. That's where the word fitting comes in. When we find a regression, we're not just finding an equation, we're somehow finding the best equation that can model the data that we happen to be seeing in our situation. And so because we're going to, in this week's material, work with some larger data sets. Maybe I have 10 data points, maybe I have 15, 20, 500, 1,000. Whenever we work with large sets of data, technology is going to be our ally here to actually do the heavy-duty computation to figure out how to fit an equation to the set of data as best as possible. So here's where I want to start. I'm actually going to start back here in Desmos again. This is our free online graphing tool, desmos.com. I have to apologize again up front because for some reason, whenever I live stream from my office computer now, everything is really, really slow. So give this a minute just to figure itself out here. This is really bogging my computer down today. Okay, so here's the basic idea behind how linear regression works. Oops. So in a linear regression, the first thing that happens is we get a set of data. So you give me a set of data points, or maybe I go out and I measure a set of data points. So let's put into my Desmos graph here a table of some data points. So maybe I have a data point at, wow, I've never seen it be this slow. I might be having some issues with my computer here. Just give me a second to try and speed things up again. All right, so we'll put a couple of data points down onto my graph. So maybe I'll put one here at 1, 4. All right, I don't know why this is being so very slow today. But we are not going to be able to do what we're doing today if I can't get my computer unstuck from the mud here. So I tell you what, I probably need to reboot. So we're going to pause the stream for just a minute or two, and I'll come back in a few minutes, and hopefully we'll be able to get this, get a little bit of grease in the gears here. So I'll be right back in just a couple of minutes.